Folks, we're going to do 8.3. Some more fun with exponents. So far, I'm going to give you the short version here. We've learned a few rules, right? Anything to the 0 power equals 1. Anything raised to the negative power gets moved, up or down depending on where it is. The exponent moves with it and becomes positive. So there's a couple rules that we've been dealing with. Now we're going to add a third rule to that. When you have the same base, okay, and you're multiplying, what you do is you keep the base and you take the exponents and you add them together, okay? So, for example, I'm going to do a bunch of practice because seeing these problems done is what's going to help you do some of this. So something like this, n to the negative 6 times n to the negative 9th. The bases are the same. So it's still n. You add those together, you get negative 15. Now remember, you're not done yet. That negative 15 tells that to go down. So your final answer would be like that. So you can't forget the stuff that we did before. Okay. Now sometimes people get confused with numbers. Like if you had 3 to the 8th times 3 to the 5th, people are so tempted to multiply 3 times 3 and write down 9. But the rule says keep the base the same. This is still going to be 3. But now you add those, this is going to be 3 to the 13th. Folks, I don't even know what 3 to the 13th is. That number is going to be so big. I'm not going to worry about writing that down. We'll just leave it like that because it's just so big. Okay. So you add the exponents. Now, let's do 3d to the negative 4th times 5d to the 8th. Remember, back-to-back parentheses means multiplication. These numbers in the front, they don't have an exponent. So that's just plain old multiplication. And then the d, you add those and you actually end up with positive 4. So you're done right there. Okay. I don't know why I called that one 2, but now this one can be a little bit tricky. Remember, there's an invisible 1 here. So we're multiplying, we keep the a and we add. So we get a to the 4th. Okay, that's a tricky one. Now, let me show you another type. I'm trying to show us c to the negative 7 times. Now, what a lot of kids like to do here is this negative 7 is telling that c to go up. They want to move it. Don't do that. What we want to do is combine things first. So you see how these are being multiplied on the bottom? That means you keep the c and you add the exponent, so you get negative 2. That negative 2 tells the c to go upstairs, and you get c squared. All right? Getting the hang of this, I hope? This is the new rule for today. All right? I'm going to do a few more. So let's see here. How about this? 2 to the 8th times 2 to the negative 9th times 2 to the 3rd. Again, keep the base the same. It's still a 2. Add these together. 8 plus 3 is 11. 11 and negative 9 is positive 2. Well, we can handle 2 squared. That would be an answer of 4. All right? So I hope that's it. I'll do maybe one more. 5 to the negative 6th times 5 to the 4th. Add those together, you get negative 2. That tells it to go downstairs. 1 over 25. Okay. Let me show you some of this with scientific notation. Check this out. 7 times, so we'll call this number 8. Same rule applies. Watch this. Okay. So what you do is you pay attention to the like thing. So back-to-back parentheses means multiplication. So this 7 and 5 are going to multiply when we get 35. These bases are the same, so we keep the base and we add 7 and -5 is going to be 2. Okay? Now remember though, you want to write your answer in scientific notation. This is actually not in scientific notation because this number has to be between 1 and 10. So I have to change that to 3.5. Now that's where the decimal was, and this is telling it to go 2 times to the right. I moved it the wrong direction. So I'm now farther away, so that's going to be a 3. Okay? Here, I'm just going to, 5 times 10 to the 20th times 4 times 10 to the 30th. Again, multiply, you get 20. Add those, you get times 10 to the 50th. But again, that's not scientific notation. We have to change this to 2.0, but I just write 2. Invisible decimals here, that says go 50 times to the right. We moved it the wrong direction, so I'm farther away. Let's do one more where 3 times 10 to the -20, 6 times 10 to the -10. So we get 18 because 3 times 6, and we get 10 to the -30. But remember, I have to change this to scientific notation as 1.8. That says take this and go this invisible decimal and go 30 times to the left. We actually moved it to the left to 1.8, so we moved it one step closer. There you go. So that's a little short lesson on section 8.3. Okay, little introduction, some notes, and